So the next unit we're going to be looking at is dealing with sets, sequences, and series. So a few definitions just to get started with. So first of all, a set is just defined as a collection of distinct terms. And two important things about the set. The order of the terms is not important, and the elements may not be repeated then in a set. And so if we look at just a set of letters, it could be a set of any kind of elements. Typically we'll be dealing with numbers, but it works with letters as well. So I have E, G, H, I, and T is a set of letters, 2, 8, and 16 then a set of numbers. If we look at just changing the order, if I have the E, G, H, I, T, or G, H, T, E, I, so I just switch some of the letters around, those are going to be equivalent as sets because the order doesn't matter. And again, same thing with these ones here. If we look at this one though, we have 2, 8, and 16. Here we have 2, 2, 8, and 16. Those are still equivalent sets, but this 2 is redundant. And so you normally wouldn't put that in. But if I do have repeats for a set, it's unnecessary, but it doesn't change the overall elements then in the set. So a sequence is very similar to a set, and they certainly look the same if you're just looking at them. However, the elements in your sequence must be placed in a particular order. So if you change the order, you change the sequence. And now we may repeat elements then also in the sequence, so repeats are allowed. So here we have basically two different sequences taken from this set of 5 letters. So we have some repeats, and we've changed the order, and that gives us then two different then sequences of letters. And so if we're dealing with letters, what we can do is we can view the alphabet basically as the set, and so that's just the letters we have to work from. And then all the different words that we form, those are going to be sequences. And so we can use different orderings of the letters in the alphabet. We can use repeated letters in the alphabet to make all the different words. And so if you're dealing with letters, the alphabet is the set, and then all the words that we can make then are sequences. Now in our unit, we're going to be dealing typically with numerical values, and we're going to be focused then on sequences. Now we have two types of sequences we can look at, finite sequences and infinite sequences. You just need to be able to recognize the notation for those. So with the finite sequence, if it's relatively short, I will just list all the different terms in that sequence. If it's a really long one, sometimes we'll put an ellipsis in the middle there. Now we don't have basically all those terms spelled out, but we could easily come up with what those terms are for most sequences there. But if it does have a specific beginning and end point, it's still going to be finite. An infinite sequence uses that ellipses then at the beginning or the end. So in this one here, I do have a set start point, so at 2, but this one goes off forever, and so this means that there's no upper limit to this one. We could put that ellipsis at the beginning, and so here there's no lower limit to this sequence, or we could put it on either end, and for this particular case, there's no upper or lower bound then. Now sequences then can also be recursive or non-recursive. Now in our units, we're only going to be dealing with recursive sequences, but you should know then the difference between those. So a recursive sequence is just something that you can look at a pattern and then use the pattern to generate other terms then in that particular sequence. So, and there's all sorts of different patterns we could have. So we could say have the sequence of odd numbers, and then we're just counting up all of the odd numbers and going from there. We could look at the sequence of the squared. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Or we could look at something like the Fibonacci sequence, which is a fairly common one as well, where we just add the two original terms. So 1 and 1 is 2, 1 and 2 is 3, 2 and 3 is 5, 3 and 5 is 8, 5 and 8 is 13. So if you just add the preceding two terms, then you can generate the next one. And so these ones are all recursive because as long as you know the pattern, you can then generate all of the other terms there. Now this notation here on the side is just putting it in terms of term numbers, and so T1 is equal to 3, and so then I can put in other terms overall and then generate the successive terms from there. And so if I have T2 for instance, then this becomes T2 equals T2 minus 1, which is just T1 plus 2. T1 is 3, 3 plus 2 is 5, and that gives me my next term. I can go T3, that gives me T3 minus 1, or T2, which is 5, plus 2 is 7, and then we can just carry on from there. For this one here, Tn, I'm just going to take that n value squared. So my first term, T1, is 1 squared. My second term is T2, so 2 squared, T3, 3 squared, and on from there. And then this one here is just from the two previous terms. Now we're not going to be dealing with the non-recursive sequences very much, other than just being able to recognize those. So a couple of examples that are fairly common. The set of prime numbers doesn't seem to have a particular pattern to it. So starting at 2, 3, 5, 7, and then there really is no upper limit to those, so those just do carry on forever, but there doesn't seem to be a particular pattern for how those ones are ordered. Now the alphabet, as we usually kind of list it, the order is somewhat arbitrary. If we're dealing with it as a set, of course you could just scramble those and you could still make all of the same words, but we do normally put it in a particular order then just to help us remember it. But there's no way I could look at A, B, and then somehow generate C. So it is a somewhat arbitrary order as we put those ones in. And so those would be examples then of non-recursive sequences. So for these ones here, if you know the kind of first 5, there's no way to generate the next one. Whereas with recursive sequences, and those are the ones we're going to be focused on, if you know the pattern, then you can generate basically any term based on that pattern.